Please welcome Dr. Bernd Lohmann, CTO of Bayer.
Okay, so Oliver, thanks a lot. You just need to help me with slides. Otherwise, I will not be able to convey the whole message. I put you a bit under pressure. I start already. So we will change a little bit perspective. So I'm from Bayer, so a life science company. And I'll explain to you how, of course, we do software development, but also how we handle software on a larger scale, including some of the practical problems we face day to day. And so while Oliver is still switching. And so just to give you a couple of figures in the beginning, today, and I feel a little bit bad about it, we have 6,000 applications today in the companies. A lot is legacy. And we'll talk about that. What makes sense? What makes sense in terms of DevOps? How much of these applications can be further developed based on DevOps? So we will see that also in a minute. But what I will start with, and this is really not for advertising, I will talk a little bit about Bayer. And the reason why I'm doing it is that we that we have a certain perspective on software development. We think it from the end. We don't come from the code, but we come from the business value of our organization. That's absolute key for us. 100,000 employees are asked to think a lot along those lines. And this will, and I'll come in the end to a special program where we roll out agility and DevOps kind of thinking to the whole company, even to the business. That's something we really roll out in the whole company and where we train everybody about. And that's why I just start with the lowest mission statement here underneath: health for all, hunger for none. Which is a mission statement which is absolutely encouraging for us as employees, and we get a lot of positive feedback around that. Each and every employee, be it IT, be it production, be it commercials, is asked, come from the end. The mission is we want to improve the health of the world population. That's one, our pharma business. Second is that since we have also a huge crop science business as well, we want to help feeding the world. In 20 years, we might have around about 10 billion of people on Earth, and we need to be able to feed all of them. And all this goes towards yield of fields, yield we have in the production, in the crop production. And these are the two thoughts we follow with. And starting from that, just I more or less mentioned it already, we have three divisions. One is crop science, that's the farming area. We have pharmaceuticals for patients around the world, and consumer health is the over-the-counter business, non-prescriptive drugs. We have around about, again, 100,000 employees. We just had 100,010 with SAP, so quite a large company. And another figure quite important here is 5.4 billion of invest every year into research and development. And this is really pharmaceutical research and research in the farming and crop science area. Let me quickly mention, and this still goes towards what is the aim of the company and how do we think. Crop science is innovative cropping solutions and systems. So what we are doing is that we develop crops, for example, which sustain under heavy weather conditions. If there is a storm, if there's strong wind, you might develop very small wheat. Yeah, so it just doesn't stand high. It withstands storms, winds. Meanwhile, we are able to grow corn, to grow wheat, to grow rice, and so on in areas where you wouldn't be able to grow something a couple of years ago. That's where our research goes. Pharmaceuticals is, of course, easier to grab. It's oncological medicines. It's around medicines for women health, for example, or for ophthalmology, and similar. It's for consumer health. Now the question is, what does IT, what does digital now mean in all these areas, and I'll give you a couple of examples. So, for example, we in crop science, we develop solutions which help the farmer while he's even driving on his tractor. So he can see how is the field doing, what has been the harvest just during the last 5 minutes, how much do I need to spray of a fungicide, can I minimize? And meanwhile, you utilize much less as compared to even five years ago. That's one. Another one, just this, we have very great speed and precision in trait development. These are these characteristics of corn or of wheat just to even withstand heavy weather conditions. There's a lot of technology in there. How you do that? By the way, we have up to 4 breeding cycles per year, so we can breed new types of corn, which then adapts to certain conditions for up to 4 times a year. Natural one would be 1 time, so it's up to 4 times. And then we develop new corn. And you can imagine digital health, also lots of things are out there. A lot is in research and development, genetical analysis, for example, is one, or even we have solutions for radiologists with new algorithms, AI-based algorithms. You can detect certain diseases based on a radiology image much faster than a normal human being would be able to do that. So there's a lot out there we can do, and that's the thinking we have. So we come from the end and we try to get there, which gives already a couple of messages I want to give there as well. So if we think software development, for us, this means we need people who understand, for example, genetics. So I like the example of the house this morning, which of course was an example, but for us it's not about the house. We need developers who understand a protein. We need developers who understand how a protein unfolds and interacts with other proteins. And that's the difficult piece here, to get these people, and we can debate long on education and so on, which is definitely needed. But that's the way how we approach it, and that's the way we are trying to go with all difficulties. We heard the question of who has data scientists this morning, so that's a big problem. We need also bioinformaticians, which are not that easy to get. So that's the way how we approach it. This is just a little example for illustration. That's whatever you see on a tractor. Yeah, so if somebody is yielding, you see, if you have a look at the picture at the left, while you're sitting on the tractor, you see where's my tractor on the field, what is my yield currently, where am I, what is the condition of the soil, and what I need to do next. So there's a lot of images on the fields while I'm even doing the job. So now coming more and more towards now our topic here, I talk a little bit on how we have done our digital transformation over the last many years. So 10 years ago, we started a journey which went into outsourcing, offshoring. On a larger scale, we even transferred people to offshoring providers. That was one of our first steps, just to be more productive in software development. We did a lot on cloud transformation. Basically, when we started, we wanted to move everything into cloud, public cloud in particular, as much as possible. We ended up in much more in the private cloud than we thought. This is one of the big topics I also want to mention today. We, as a large company, we have a lot on legacy software out there. Yeah, it's just things, molecular modeling and so on, which have been developed 20, 30 years ago, and things which are more or less approaching the end of the life cycle. For us, the question is, how much can we afford to touch that code? Basically, we need to keep a lot of this code. It's just commercially not reasonable to change that code. And overall, that's around about 80% of what we have. So we need to wait for the end of the life cycle. Just also to integrate a bit of what we said today. We had nice comments from SAP, for example. We still live on the old ECC world. Yeah, SAP ECC, yeah, so S/4HANA, the journey is just starting. That's for us legacy software, and the developments we had there, that's legacy. There is not much with AI and so on we can do there. Yeah, so that's the reality we are facing. We might not be most advanced. I'll touch a couple of things where we are doing something, but that's where we are living, and we have lots of software we needed to develop on our own in very specific fields. Just think about the crop examples before. There are solutions out there, hardware and software, where you plant, where you do automatic planting. There are 3 companies around the world who might be doing some similar things, but that's nothing you can buy. And these are things we need to develop on our own. And all what we have developed some 10 years ago, it's old-fashioned code. Yeah? So we cannot really touch it and just wait for the end of the life cycle and then move it forward. Then we had, that's the green field here, some pragmatic area where we just worked on governance and governance practices. That's what we heard about architecture, to set a couple of standards so that our software developers didn't just buy in and adapt and develop things all on their own. Our experience is also related to the first topic here. If you talk about agile development, in offshoring we saw a lot of resistance, by the way. So many people saying, hey, we are doing agile and offshoring is impossible, just leave me alone. Where we in the end said, hey guys, it's great to do agile software development, but that's not chaos. You just cannot do whatever you want and just block off everything we want to do. That was a big discussion we had in-house. And so in the end, we found some solutions around that. But as you can see, we really needed to establish a couple of really quite strong governance practices here. And we also redesigned our whole infrastructure quite a bit, software-defined, data center software-defined, wide area networks, local area networks. So quite a bit we needed to change over there. Also do quite a bit of re-engineering to move more towards the public cloud, which is something we are doing now. And then the next big topic, all with regard to AI and further developments, is data silos. We had data silos. There was a silo in R&D crop. There was a silo in R&D pharma. No integration between production and for example, R&D data-wise. So we needed to start to connect these data. If I do pharma research and do some trials on a patient, this is still a patient if I look at it from a commercial standpoint. And the data were not integrated at all. So that was a big topic. So some 2-3 years ago, then we really redesigned our agile development practices, all the tools we have heard about, GitHub and so on. That's of course something we meanwhile utilized as well. But this was only the 3rd step on our journey, and we are step by step getting to it. And then we got more and more detail into AI. So since 2 years, we of course look at Gen AI, we look at chatbots, we utilize Copilot, so a lot is out there. And then, and this is the last point, which is quite modern, I find it very encouraging, very interesting. This is something we call dynamic shared ownership. And this goes back, for those who know Gary Hamel, there is a book called Humanocracy, where basically you apply the ideas of agility, DevOps, to a whole company. Basically, since 1 year, we are turning the whole company upside down. Everywhere in production, in commercials, we are working in 90-day cycles. We are breaking it down to 2-week cycles, even to daily sprints. We are going down. Also in areas which are not at all directly related to IT, which will turn the whole company around. Also the way we are thinking. We will cut down hierarchies quite dramatically, and even if you read the public press, some announcements are out there how many people we just recently released, also managers. So this is a dramatic change, and what we will move to is very agile squads. Squads we can set up really within a couple of days, where people from business, as said before, who really in detail understand all this genetic stuff I've been talking about, some software developers, where we get them together to really do modern and new software development. So the focus here is really on the differentiating piece for us. What makes us special as Bayer? what is our competitive advantage. That's where we focus on in our more modern, agile software development. That's what you see on the right-hand side over here, with all the tools, as I said, which are out there and which we discussed. But this is only 20%. 80% is on the left-hand side. So I'm responsible for kind of, we have 6,000 applications, 5,000 are more on the left-hand side, and we are optimizing that, cutting down costs. That's standard. That's not the area where we really make money. The money we do on the right-hand side, which is differentiating, and that's where our focus is on. So finally, just a couple of remarks on Gen AI, but that's more or less a repetition of what we heard from you, Johannes, from other colleagues this morning. Of course, we are venturing into that, and we are utilizing that, it's a very interesting field. So we have an agile community, some 300 people working together, software development, Gen AI-based software development, but also our experience is you need to be well trained. Yeah? You need to understand what is generated there. I tend to explain it in the companies, hey guys, if you utilize Gen AI, ChatGPT and so on, sometimes there's just not reasonable information coming out. And of course, the same happens in code generation. Sometimes it doesn't make sense or there are errors in, and you need to be well trained as a development to see where are these areas and where do you need to look at. So that's our experience we have there. A very important topic is for us sensitive data. Yeah, from all what I said before, you can imagine patents play an important role for us. Patent duration is 20 years. If we do that for pharma, the first 12 years are lost before the product launch in the end. It's just getting all the approval from authorities to get there. We invest for a new medicine, like an oncology medicine, around about 1.4 billion for a new medicine there during the first 12 years. And then the marketing phase starts. So we need to earn that money then in the remaining 8 years, which is sometimes quite tough. With this, you can imagine it's an absolute catastrophe if we have a new medicine. Let's stay with oncology, a new oncology medicine, and suddenly the information goes out. And that's what you need to make sure. If you utilize Gen AI in our companies for whatever purposes, be it code generation, be it whatever, providing test data, but be it also just for the lab journals we have in research, we need to be damn sure which kind of data do we have in there. We do our own training. We have our own language models here just to be sure that we know what is happening over there. And then maybe one final point which was not stressed too much. And by the way, there was yesterday also was an event here in Berlin with some members of the German Parliament because of all our infrastructure we have in, for example, Germany. Basically, if we apply Gen AI, if we apply artificial intelligence, we are running into a significant gap of compute power, of network bandwidths. We even at Bayer, we think if there's around Frankfurt a large internet node, we even believe we will need a second one over there. If you just imagine that we utilize Gen AI for code development, for other purposes, for 100,000 employees within Bayer, we would have a massive infrastructure problem. This is often forgotten, yeah? So that this needs also infrastructure capacity, where we see much more of a discussion needs to be led. That's why, by the way, there are these discussions also with in this case, the German Parliament. That's an aspect which is extremely important. Otherwise, and then coming back to the commercial aspect, we will not be able to afford. Yeah, I cannot double, triple my capacities every year if this continues. It's just not commercially affordable. So that's a big topic for us if we think about scaling up. So I hope it was interesting, maybe a little bit of a different perspective here and there, but I thought, and Oliver and myself, we discussed it before, and it might be interesting aspects here. And then give it, Oliver, back to you. You are the moderator.
We are ahead of time, so I'd just like to ask a question. You had this interesting balance chart, yeah, where you're saying that the old world is on the left-hand side.
Yeah.
This one, yes. How much of your resources, just in percentages, do you spend on the left-hand side, and how much do you spend on the right-hand side? Because you said, well, earning money is on the right-hand side. My assumption would be that you have to spend more on the left-hand side.
Yeah, that's a very good question. Basically, to be honest, we don't know it exactly. And the reason is, left-hand side, we work a lot on offshoring. We have around about 7,000 people, more or less, in India working for us. And these are managed services contracts in quite some cases. So we don't know exactly how much is there. Of course, I can look at it commercially. It's, I would agree, it's the most is on the left-hand side, while we have, in particular on the right-hand side, around about 300 developers on our own developing these new things. But you're right, the big investments is still on the left-hand side. And I gave the example of SAP ECC. Yeah, so it's an enormous invest for us, and now we even to prepare. We have continuously right now, and then we need to prepare for S4HANA. That's where still the money lies. So your assumption is correct.
And I think that is that we always have to keep in mind. Well, today we were talking a lot about Gen AI and the future and where is it, but well, as for every transformation, legacy is a problem. So
exactly,
you have to overcome that. And if you have 7,000 people on the left-hand side and 300 on the other one, well, that tells everything.
Exactly. But there we might have not do the best job here. I don't know. I think, but I just wanted to convey a little bit the reality. How does it look like in daily work, in our daily work? Yeah.
Thank you very much.